What's up, guys? My name is Kyle, and I'm the founder of Strive Scholars. And today I'm going to be solving 5 hard SAT geometry questions for you live. Make sure you save this video, take the strategies I'm about to show you, and apply it to your next practice test or real SAT attempt. And if you'd like to very systematically learn all the skills required of you on the SAT, comment the word roadmap below and I'll help you get started. But with that, let's get into this first one. So here in this question, we have a circle that is located at, with the center located at -1, 1, and there's a line that's tangent to the point 5, -4 on the circle. And we want to know what other points also lie on the line T. So if we were to visualize this, we have a circle, okay? Sorry, poorly drawn circle, but let's say that's a circle, and the center is right here. -1 and 1. And this point 5 comma -4 is probably down here somewhere. 5 comma -4. And what we're being told is that there is a line T that is tangent to this circle. So having a line that is tangent to any shape means that it only intersects at that one point. Okay, so line T may look like this. Like this. It's just intersecting the circle at that one singular point right there, which is 5 comma -4. Now, an extension of a line being tangent is that this word tangent essentially means perpendicular. Okay, so if I were to draw a line from the center to the point 5 -4, so that green line right there, this would actually make a 90-degree angle with that tangent line, the red tangent line right there. I know it doesn't look like it, but pretend like it's drawn perpendicular. Okay, so now that you know that the green line and the red line are going to be perpendicular, that's very good because what do we know about the slopes of two lines that are perpendicular? So let me write this out for you. So perpendicular line slopes. I want you to remember the phrase negative reciprocal. So two lines that are perpendicular to each other, their slopes will be the negative reciprocal. Okay, so you take the negative of a number, then flip it around, right? So as an example, um, 5/2, take the negative of it, becomes -5/2. You then take the reciprocal, right? Becomes -2/5. And so if you have a slope, you have a line with a slope of 5/2. The slope of that perpendicular line to that original line will be -2/5. That's what negative reciprocal means. Okay, so now knowing that, that lends itself very nicely to how we can solve this problem. So there are a couple steps here. First, I am going to find the slope of the green line. Okay, I have those 2 points on the green line, right? The center of the circle, the point 5 comma -4 on the circle. I can use those 2 points to find the slope. Now, the second thing I'm going to do is I'm going to find the slope of the red line. And I can do that because I know the red line is going to be perpendicular to the green line. So I'm going to find the negative reciprocal slope. That tells me the slope of the red line. Okay. And then third, what I'm going to do is I'm going to find the equation of the red line. And by equation, I mean, you have a line, right? So the equation is y equals mx plus b. And I can do this now, right? Because I know the slope of the red line. I have 1 point on the red line. I can find the y-intercept of the red line, and I can therefore find the equation of the red line. So let's see what this looks like. So step one, I'm going to write this up here. Step one. All right. So remember how you find the slope, right? y2 minus y1 divided by x2 minus x1. So slope of the green line is going to be, -4 minus 1 over 5 minus -1. And this gives me -5/6. So that's the slope of the green line. Now for the slope of the red line, I'm going to take the negative reciprocal, right? Because these two lines are perpendicular. And so what's the negative reciprocal of negative 5, 6? I take the negative, that gets me to 5 over 6. I take the reciprocal of that, gets me to 6 over 5. So I know the slope of the red line has to be 6 over 5. All right, so now we have the slope of the red line. We have 1 point on the red line. Let's find that equation. So y equals mx plus b. Let's plug in the point. So y equals -4 equals the slope, which I know is 6 over 5, times the x point, which is 5 plus b. Now b, the y-intercept, that's the only thing I don't know. I can solve for b. And when I do, when I solve this out for b, I'm going to find that b equals, -10. And so the red line equation, that's going to be y equals 6 over 5x minus 10. All right, we're almost there. Question's asking us which of the following points also lies on line T. So this line, right, is a function that governs every single point on that line. Said a different way, if I take any point on that line and I plug it into this equation, the equation needs to be true. So let's plug in each of these and see which of them would be true. Okay, so option A is 0, negative 0, 6 over 5. If I plug it into our line equation here, I see that that's not true, right? So can't be option A. 4, 7. Plug in x equals 4, y equals 7. Again, not going to be true. So I know that's not true. 10, 2. So this actually does work. I plug in 10 for x. I do get 2 for y, which is what we want. And then just for completeness, let's check that last one. 11 and 1. That won't get us what we want either. So we know indeed that the answer has to be C. Okay, that's the first one. Let's go to the second question here. And so here, we want to find the unknown angle x. And it's giving us a few pieces of information to get started. So first, VST, this angle right here, is 29. RVS, this angle right here is 41. And we also know that RT equals TU. So these two sides are the same. The sides of those triangles are the same. Now we want to find the value of x. Okay, so how can we get started here? We're going to take advantage of a couple key angle relationships here. So the first one, right? If I have an angle or two angles like this that are like, they're on the same line, the line gets split in half, but I have two angles like right next to each other like that. I know that these two angles will sum to 180 degrees. Okay, adjacent angles, sum to 180 degrees. That's the first thing. Second thing I'm going to take advantage of is that a triangle sums up all the angles of a triangle, sum up to 180 degrees. Okay? The last thing I'm going to take advantage of is that, especially in a triangle, if if two sides of a triangle are actually the same length, which is what we have here, right? RT equals TU, then it turns out that their base angles are going to be the same as well. And if you need some help convincing yourself why that's the case, an angle basically tells you how much you're opening up, right? How much the angle opens up. And then, the side length across from the angle, depending on how much the angle opens up, that angle will have a different length, right? And so if that length is the same, that means is the angles quote unquote opened up by the same amount. And so that's why if, especially in a triangle, right? If your side lengths are the same, then your base angles have to be the same as well, because it means that intuitively the angles opened up to the same amount. So we're going to take advantage of these three things to to solve for x. And so the first thing, most obvious angle that we can find right now is this one right here, because it's right next to the 41 degrees. And we know that two angles next to each other like that have to add up to 180. So we know that this angle is 139 degrees. That's number one. Now, take a look at this triangle right here. This purple triangle. We can form a triangle here, right? And every single triangle, no matter what it looks like or how big it is, all three angles in that triangle add up to 180 degrees. So we already have 139. We have 29. And so this last angle right here has to be 12. Right? Because now the three angles will add up to 180. And what did we say before, right? The two side lengths, TU and RT, are the same. Their base angles are the same. So the base angle of TU is 12. This angle R right here also has to be 12 because its base angles are the same, right? For side lengths that are the same. And so now, if you look at this, well, let's see, let's make it red. You look at this red triangle right here. We know two of those angles, right? We know angle U, angle R, they're both 12. So these two angles, 12 plus x, has to add up to 180. So what value of x makes this actually add up to 180? We know that x will have to be, so 24, 180 minus 24, 156 degrees. That's going to be our answer here. X equals 156 degrees, and all we did was utilize those three key angle relationships. We kept finding the quote unquote next angle, and we eventually got to the one that we want. That's it here. All right, let's go on to the next question. So here, we have a right triangle. Measure of angle Z is 33, length of YZ is 26. Area can be represented by K times tangent 33. We're asked to find K. All right, so if we visualize what this looks like, you have a right triangle. Angle Y is the right angle, so Y is down here. Measure of angle Z, say this is Z, and X. You know that this is 33 degrees. YZ is 26. Okay. So now we want to find the area, this entire triangle. And so as a reminder, your area equals 1/2 base times height of a triangle. Now, if we plug in the things that we do know, we have area equals 1/2 times the base, which is 26. The height is xy. Whatever the length of xy is, that's going to be our height. Problem is we don't know what xy is out of context. But I want you to recall your trig functions, sine, cosine, and tangent. Xy right here. Let's call that x. And think about like you have the base 26, you have that angle 33. Which of your three trig functions, sine, cosine, and tangent, capture the relationship between this 33, the 26, and x? Well, sine is opposite over hypotenuse. We don't need the hypotenuse here, so not sine. Cosine is adjacent over hypotenuse. Again, we don't need the hypotenuse. But tangent is opposite over adjacent. And that seems to work here because now we can say that tangent of 33, right? The angle in the bottom right corner here, equals x over 26, x being the length of xy, the height of our triangle here. And if we wanted to get xy or x by itself, then we multiply 26 to both sides and we get x equals 26 times tangent of 33. Now we know what the height of this triangle is. 26 tangent 33. Yeah, that's something you can punch into the calculator. That is something that, you will get a clean number here. But now we know what the height is, right? And so we can plug in that height into the area equation. And so now we get area equals 1/2. times 26, which you had before, times the height, which we just found is 26 times tangent of 33. And this is perfect, right? Because they're asking us to express the area as k tangent of 33. So we want the tangent of 33 to stay in the area formula. And now 1/2 times 26 times 26. That's going to be some number times tangent of 33. And when you put this into your calculator, you get that the area is 338 times tangent of 33. And this is great news. That means our answer here is like k equals 338. Now, as a recap, he took advantage of two things, right? Biggest thing was we took advantage of our trig functions and we created an equation using the things that we know and the thing that we want, which is the height of this triangle. We use that tangent relationship to find the height of that triangle. And so now after doing that, you plug back into the area formula, which area of a triangle is 1/2 base times height. We're able to solve for what they want us to find, that coefficient k. That's all it is here. Taking advantage of the trig functions that you already know. All right, let's go on to the next one. So here we have rectangle ABCD similar to another rectangle. The area of rectangle ABCD is 648. Area of EFGH is 72. And so the length of the longest side of ABCD is 36. What's the length in inches of the longest side of EFGH? All right, so if you set up a ratio here, right? 648. Let's set up a ratio between the areas, these two rectangles. So area of ABCD over EFGH equals 648 over 72. That's 9. And so what that means is the area of ABCD is 9 times bigger than the area of EFGH. Here's why that matters. So I want you to imagine two rectangles, okay? Two similar rectangles. So let's say the smaller one, the sides are 2 and 4. Bigger one, sides are 4 and 8, let's say. Pretend like that's drawn to scale. Now, what is the area of the smaller rectangle? It's going to be 8. 2 times 4, right? Length times width. Now, what's the area of the bigger rectangle going to be? 4 times 8 equals 32. I want you to notice something here. Every side length in that bigger rectangle is twice as big as the side lengths in the smaller rectangle. But the area of the bigger rectangle is 4 times as big as the area of the smaller rectangle. And if you write out the equation, so like the area of a rectangle, right, is length times width. Using that equation, it's actually easy to see why. Because, let's call this area 1 is the area of the smaller rectangle. And it's length times width, right? How do we get from the smaller rectangle to the bigger rectangle? We made every side length twice as big, right? 2 became 4, 4 became 8. And so the area of the second rectangle comes about from doubling the length and doubling the width. And when you multiply everything out, right, that becomes 4 times the length times the width. And that's why the area is 4 times bigger. Now, how does that help us out here? We know that, in our situation, right, situation that they give us, area 2 is 9 times bigger than area 1, right? So that's, 9 times the length times the width. How much bigger did we have to make the length and the width? It's 3, right? Because, we had like 3 times the length, 3 times the width. That really would get us to 9 times the length times width. So because the area is 9 times bigger, we know that the side lengths have to be 3 times bigger. Like 3 times bigger than the side length, each side of A, B, C, D has to be 3 times longer than the side lengths of E, F, G, H. And that applies to the longest side as well, right? So if the longest side of A, B, C, D is 36, and that's 3 times longer than the longest side in E, F, G, H, then that tells us the length of the longest side in E, F, G, H, and that has to be 12 here. The key takeaway is that using similarity and using the equations for the area, we can essentially mess with that equation, right? If two shapes are similar, every single side length is scaled by the same amount. And when you scale that side length by some amount, you're going to get a final change in the area, right? Double the length and the width, get 4 times the area. Triple the length and the width, you get the 9 times the area. And we're using the equation to show why that's the case. And that is basically what this boils down to here. All right, I have one more question for you guys today. And that's this one. So you have this, triangle set up here, and they're asking you for essentially the height of that triangle. What is the length of NQ? And the trap that many people fall into is, they'll use Pythagorean theorem, they'll set up a bunch of systems of equations, but that takes forever to do. And that's actually it's actually a pretty involved thing. The shortcut you can take advantage of here for anything like this that you'll see on the SAT, I want you to remember this. Shape inside a shape will be similar. And real quick reminder on what it means for two shapes to be similar. It means they have the same exact angles and they have a fixed ratio between their side lengths. So how does that help us out here? We know that there are 3 triangles in here, right? Triangle 1, triangle 2, and then the big triangle, M, N, and I think that's P, M, N, P. All 3 of those triangles are going to be similar to each other. And so looking at those 2 triangles, that smaller triangles that we have, triangles 1 and 2 are also going to be similar to each other. Now we're going to take advantage of the fact that they will have this fixed ratio between their side lengths. Okay, and here's how we're going to do that. We're going to set up a ratio. Okay, so what is the hypotenuse of triangle 1? It's 3. What is the hypotenuse of triangle 2? It's gonna be 4. And what's the hypotenuse of that entire big triangle MNP? It's gonna be 5. So looking at the big triangle, right? We know that we have a 3, 4, 5 triangle. Now, what did we say earlier? Every single triangle here, triangle 1, triangle 2, and also the big triangle, all 3 of them will be similar to each other. They will all be a 3, 4, 5 triangle. They will just have slightly different ratios between the side lengths. They'll have a fixed ratio between the side lengths. And so if you take a look at a 3, 4, 5 triangle, right? The shortest leg is 3x. This longer leg is 4x. The hypotenuse is 5x. Now, what's the ratio between the longer leg, 4x, and the hypotenuse, 5x? Well, that's easy, right? That's going to be 4x over 5x. equals 4 over 5. The reason why this helps us is because NQ for triangle 1, that is the longer leg, right? Just visually, you can tell that NQ is bigger than MQ. And so NQ, from the perspective of triangle 1, is the longer leg. And we know that that triangle 1, right, is still a 3, 4, 5 triangle. Shortest leg is 3x, longer leg is 4x, hypotenuse is 5x, right? So we're going to take advantage of that, okay? So we know that NQ is the longer leg. We know that the hypotenuse is 3. And we know that this ratio is going to be 4 over 5 because all the triangles are similar to each other. And so by taking advantage of similarity, we can very easily now just use a simple ratio to find the height of NQ. And solving this out, cross multiplying, getting NQ by itself, you see that NQ is going to be 2.4. That's it here. So instead of trying to solve a bunch of equations with Pythagorean theorem, we actually took advantage of similarity and setting up ratios between the side lengths using similarity to actually very easily solve this question here. So that's it, guys. Thank you all for tuning in. And if you want to see some more breakdowns of some hard SAT questions across the different math and English categories, follow for more. I do one every week, and I'll see you guys in the next one.